Welcome to the Modern Software Factory. We're going to take you on a tour of the high-tech assembly line that transforms a simple thought into the apps that you use, well, every single day. Let's dive in and see how it all works. So, have you ever really stopped to think about that? How does a spark of an idea actually become a real working app on your phone? It kind of feels like magic, right? But behind that simple little icon is this incredibly complex, super fast-moving process. We're going to pull back the curtain and walk you through that entire factory from start to finish. All right, so every single app starts, well, not with code. It starts with a conversation. A business sees an opportunity. A customer has a pain point, and that initial spark, that what-if moment, gets hammered out into a real plan that developers can actually start to build. Now, to manage all this chaos, modern teams don't just try to build the whole thing at once. That's a recipe for disaster. Instead, they use a framework called Scrum. The core idea is simple. You break the giant project into tiny, manageable pieces. This way, the team can deliver real, working features to people fast, instead of making everyone wait months for some big bang release that might be all wrong anyway. And this whole process really clicks because everyone has a clear role. First, you've got the product owner. Think of them as the visionary, the voice of the customer. They decide what needs to be built. Then there's the Scrum Master. They're like the team's coach or referee, making sure the process is running smoothly. And finally, you have the Scrum team, the developers, the testers, the designers. These are the folks in the trenches, the experts who figure out how to actually bring that vision to life. The work happens in these short, intense bursts called sprints, usually about 2 weeks long. In every single sprint, the team plans what they're going to do, they build a small usable piece of the app, they show it off to get real feedback, and then they huddle up to figure out how to be even better next time. It's this constant rhythm: plan, build, review, repeat. Okay, the plan is set. The team knows exactly what they need to build in the sprint. Now it's time for the fun part. It's time to actually write some code, the digital bricks and mortar of our app. You know, when you strip it all away, all software is really just text. It could be a super sophisticated program in a language like Python, or something as basic as a script that just says, "Hello world." But every amazing, complex feature you love starts right here, with fundamental lines of code. But wait a second. If you have a whole team of people writing code at the same time, isn't that going to be a total mess? Well, it would be without a version control system, or VCS. You can think of it as a time machine for your code. It tracks every single change, who made it, and why. It's the key to preventing chaos and letting everyone work together. And this technology has come a long way. Back in the day, systems were centralized. There was one main server, and if that server went down, well, everybody went home. Work just stopped. But today's standard, Git, is a total game changer because it's distributed. Every single developer has a full copy of the entire project history on their own laptop. It's faster, it's more flexible, and it's practically bulletproof. All right, we've got our code, and we have a system to keep it all organized. Now we're stepping onto the main factory floor. This is where the real magic happens, where automation takes over and turns that raw code into a working product. This is the world of CI/CD. So the first piece of this puzzle is called continuous integration, or CI for short. It's a really simple but powerful idea. Developers are constantly merging their code into one shared place, sometimes dozens of times a day. And every single time they do, an automated process kicks off that builds and tests everything to make sure the new code didn't accidentally break something else. And this is that automated assembly line in action. A developer commits a change. Boom! An automation server instantly grabs it, builds the app from scratch, and runs a massive suite of tests. This happens for every change, which means bugs are caught in minutes, not weeks later. And if everything passes, that code gets a green light and is ready for the next step. Of course, this factory doesn't run on its own. It's powered by some seriously heavy-duty tools. You've got Git acting as the code librarian, an automation server like Jenkins playing the role of the factory foreman, and tools like Ansible that help set up all the machinery. These are the absolute workhorses of modern software development. Okay, check this out. Our code has been written, it's been built, and it's passed all its tests with flying colors. It's ready to go. But how do we actually get it from a server somewhere to the phone in your hand? Well, that is all about packaging and deployment. The old way of doing this involved something called virtual machines, or VMs. Think of a VM as a whole separate house for each application. It's got its own plumbing, its own foundation, the whole 9 yards. It's very isolated, but also incredibly heavy and inefficient. Today, we use containers. This is way smarter. It's like giving each app its own perfectly sized apartment in a shared building. They're lightweight, they're efficient, and they start up in a blink of an eye. And when you hear people talking about containers, they're almost always talking about Docker. A Docker container is exactly like one of those big metal shipping containers you see on boats. It packages up the app's code, plus everything it could possibly need to run. All the libraries, all the settings, everything. And the beauty of this is that it completely solves the age-old developer problem of, well, it worked on my machine. So one container is great, but what about a massive app like, say, Spotify or Airbnb? They're not running one container. They're running thousands, maybe millions of them. How on earth do you manage that? You need a conductor for this massive orchestra. And that conductor is Kubernetes. It's the master brain that automatically deploys, scales, and manages all of those containers to make sure everything runs perfectly. And we're live. The feature is out in the wild, in the hands of real users. But guess what? The job isn't over, not by a long shot. Now we have to watch it, making sure it's working flawlessly for everybody. And here, we need to understand a really key difference between two words: monitoring and observability. Monitoring is like the smoke detector in your house. It just tells you if something is wrong. It beeps and yells, hey, there's a problem. Observability, on the other hand, is about understanding why. It's like having security cameras and blueprints to tell you exactly where the fire started and what caused it. It's not just knowing the what, it's knowing the why. And to get that superpower of observability, teams use some absolutely amazing tools. You have things like Prometheus, which is this relentless data hound, just gathering every metric you can possibly imagine. And then you have Grafana, which is like the artist that takes all that boring data and turns it into these beautiful, powerful dashboards that give engineers a real-time pulse on the health of the entire system. So we've gone from an idea all the way to a live feature being watched in the wild. But maybe the most important thing to get here is that this is not a straight line. It's not a one-way street. It is a continuous, never-ending loop. And this whole philosophy, this entire way of working, has a name: DevOps. It's built on these core pillars. You are continuously integrating code, continuously deploying it. You're automating absolutely everything you can, and you are continuously monitoring the results. It's a cycle that just feeds itself, getting faster and more reliable with every single loop. But really, when you boil it all down, DevOps is about one thing: people. It's about breaking down the walls between the teams that build the software, the devs, and the teams that run and maintain it, the ops. When those teams stop throwing things over the wall and start working together, the whole factory just works better, faster, smarter. So there you have it. That's our journey through the modern software factory, an incredible engine of automation and human collaboration. But things are changing, and they are changing fast. As powerful AI and large language models are starting to write their own code, fix their own bugs, and even design systems, it leaves us with one heck of a question. What will the factory of tomorrow even look like?